Good day all, and welcome once again to my YouTube channel. So today we are going to be looking at the concluding video of our variation class, and that is joint and partial variation. In our previous video, we considered direct and inverse variation. Alright, so now we'll start by looking at joint variation. When we talk about joint variation, the word joint means two or more things together. And of course, you ought to know that joint variation talks about a quantity that is actually proportional to more than one quantities. So it's just like you having x to be proportional to y and z. You understand the point? So in this case, a given quantity x is proportional to more than one quantity y and z. Now, this proportional could be direct, it could be inverse, or even both. So it means that we could be having x to be directly proportional to y and z, or we could be having x to be inversely proportional to y and z coexisting. You see the twist now, that I'm mentioning y and z together, meaning that they are together, they are jointly bound together. You understand the point? All right. So now I can give you an expression. If I am told to represent x is directly proportional to y and z, it means it's going to be represented as x is directly proportional to y and z. You understand the point? This is joint variation in that a given quantity is directly proportional to y and z coexisting, so more than one quantity. Then we could also have x to be inversely proportional to y and z. This is also joint variation. Or you could even be having that x is directly proportional to one of the quantities y and inversely proportional to the other quantity z. We can represent it as x directly proportional to y and inversely proportional to z. This is also joint variation. So we could have any of these representations to serve as our joint variation. All right. So we are going to see questions to better understand what joint variation entails. All right. So let's look at some questions. Okay, now the questions are written on the board. We are having two questions for joint variation. The first is, if f varies jointly as g and n such that f is 150, g equal to 3, and n equal to 10. Find the equation connecting f, g, and n, and the value of f when g is equal to 6 and n equal to 15. So let's dissect this question. If f varies jointly as g and n, so it becomes solution to the first question. F varies jointly as g and n. All right, and then such that f is equal to 150, g equal to 3, and n equal to 10. So now remember that when you introduce a constant from this point, it becomes f is equal to k g n. All right, so we are given the value of f, g, and n in order to get the value of the constant, so as to get the formula that will show the relationship amongst the three entities, all right, or quantities. So in this case, we have our f to be 150. So in place of x, it will be 150 equal to, then k unknown, that's the constant, then g is given to be 3, and n is given to be 10. All right, so that becomes 150 equal to 3 times 10 is what? 30. So it's called 30k in this case. All right, so you divide both sides by 30 to get the value of k. So when this one cancels, then 0 cancels, then 3 into 15 is what? 5. So that becomes our k is equal to 5. So if our k is 5, then we can now come to this formula here, this equation here, and get the formula that is connecting f, g, and n, and that becomes f is equal to, in place of k, we will now put 5, and then g, n. So this is the formula that is showing the relationship amongst these three quantities. Don't forget that, all right? After you have already introduced your constant, the value of the constant, then you get the formula. Then let's continue. They said we have gotten the equation connecting f, g, and n, which is this, and the value of f. So we don't know the value of f. when g equal to 6 and n equal to 15. So we come to this place, we are told to find the value of f is unknown, so 5, and our new g value now is what? 6. So put 6 times, then our n value is what? 15. All right, so when you do that, our f would now be 5 times 6, that's 30, and of course 30 times 15, that becomes 450. So our f is 450. All right, so that is the answer to the question. That is our f value. Then to question 2. Solution to question 2 now. If y varies directly as the square root of z. In my previous video, I told you guys that there is the difference between square and square root. So you can refer back to our first video on direct and inverse variation for that. And inversely as x cubed. And y equal to 12 when z equal to 9 and x equal to 2. Find z when y equal to 8 over x cubed. So let's go. First, we have to represent the equation. That becomes if y varies directly as the square root of z and inversely as x cubed. So let's go. That becomes y varies directly as the square root of z and inversely as x cubed. So we've represented it. Now, if you introduce a constant from here, it becomes y is equal to k root z over x cubed. So now we are given the value of y, z, and x. Our y value is 12, our z value is 9, our x value is 2. So in place of y, I put 12 there, equal to, then k, then what's our z? Our z in this case is 9, and our x is 2, so 2 cubed. That becomes 12 is equal to, we want to get the k value now, so root 9 is 3, so that's 3k over 2 times 2 times 2, that's what? 8. So when you cross multiply, it gives you what? 3k is equal to 12 times 8. And of course, when you divide both sides by 3, you have 3 into 12 is what? Is 4. And then 4 times 8 is 32. So your k is 32. So we now come to this formula, this one rather, and then we impute our k value in order to show the formula that is actually connecting the three quantities, y, z, and x. So it becomes, in place, okay, that's y, in place of k now would now be 32 from here, and then root z, then over x cubed. All right, so this is the formula that is showing the relationship among y, z, and x. So very, very important. Then let's see, we are told in the question that find z when y equal to 8 over x cubed. So we are told to find z, very easy. Our y is given to be what? 8 over x cubed. So in place of y, it becomes 8 over x cubed equal to 32 root z, then over x cubed. Since we have common denominators, you can easily strike out. All right, and then you are left with what? You are left with 8 equal to 32 root z. And to make the root z stand on its own, you have to divide both sides by 32. And when you do that, this 32 will strike out, and then 8 into itself is 1, then 8 into 32 is 4. So that becomes our root z is equal to 1 over 4. But when we told to find root z, or we should find z, of course, on the question, find z. All right, so for you to eliminate the square root, you have to take the square of both sides, and that becomes taking the square of this side and taking the square of this, because it's only square that can eliminate square root. So this will cancel out, you are left with your z, and then 1 square is 1, and 4 square is 4 times 4, that's 16. So our z is 1 over 16. So is that easy? So that's, you can even try your hands on some questions, but if you are not clear with anything, you can revisit the video and rewatch so that you get the clear concept, all right? So the next would be on partial variation. Partial variation is a kind of variation that is characterized by two different constants. So how do you identify partial variation questions? There are questions that come in the form of you having two constants. And these two constants that you are having, one is actually staying on its own, then while the other is usually attached to the other quantity. So when we start by looking at questions, you get to understand it much better. It's just like humans. Of course, there is something that is so constant throughout our life, and that thing is actually family. Of course, our family is constant, it doesn't change. But then again, there are some things that are subjected to changes. What are some of these things? We have the height. Not only that, as you grow up, you tend to probably experience changes in the number of your friends. So those are things that are subjected to changes. All right, but it still remains the same person. You get the point? So now, when you are giving questions in partial variation, like I said, two constants, one stays on its own while the other is attached to the other quantity or variable that is given in the question. If I say that t is partly constant and partly varies directly as b, the interpretation of that is that first, you are only interested in the two quantities. T varies directly as b. That's it. And then in obedience to that statement, it becomes t, which is partly constant, and the introduction of the first constant, and then plus the second constant that is attached to the variable, which is b here, that's kb. So usually in partial variation, you're having two different constants, all right? So don't forget that. So in this case, this is the expression having the two different constants, all right? So we are going to be looking at questions that are related to partial variation. We'll see two questions so as for you to better understand stuffs about partial variation. Okay, now to the partial variation questions. We are having two questions here. And the first question, let's deal with the first question. So solution to number one. If t is partly constant and partly varies directly as f, and t is 6 when f is 2, also t is 18 when f is 10, find the equation connecting t and f and the value of t when f equals to 12. So let's get started. The first thing you should do is that you link the t to the f, and you know that they are actually linked by direct variation. So it becomes t is directly proportional to f before introducing the constant, because now in the question they said if t is partly constant, meaning t is partly constant and partly varies directly as f, so it becomes kf. In partial variation there are usually two constants. One constant is attached to the other quantity, then while the other constant is standing on its own. So now to the question, our t is 6 when f is 2. So that becomes, in the first statement, t is equal to 6 when f is equal to 2. And in the second statement, t is equal to 18 when f equal to 10. So t equal to 18 when f equal to 10. So this ultimately will result in simultaneous equation, all right, when we substitute. So in the first equation, that's this expression here, our t is 6 then equal to a plus, in place of f it becomes 2, so that's 2k, equation 1. Then equation 2, we have 18 in place of t equal to a plus then 10k, that's equation 2. All right, so what are we supposed to do? We can subtract equation 1 from equation 2. So equation 2 minus equation 1, that becomes 18 minus 6, that's 12, equal to 8 minus 8, that's 0. Then 10 minus 2, that's 8k. So let's get k. We'll divide both sides by 8, and when we do that, 8 will strike out, and then you can reduce this by 4, that's 2 by 4, that's 3. So it becomes k equal to 3 over 2. So we can substitute 3 over 2 for k in any of the equations. So we can use equation 1. So in place of k, we put 3 over 2. So 6 equal to a plus 2 times 3 over 2. These two will cancel, we are left with what? 3. So 6 equal to a plus 3. And when you collect like terms, it becomes 6 minus 3. Because when it crosses, it turns minus, equal to a. Therefore, our a equal to 3. So if our a is 3 and our k is 3 over 2, then from the question, they said find the equation connecting t and f at first, And of course, how do we get the equation? By simply substituting k value and a value into this. So the equation becomes t equal to, our a is 3, so 3, then plus our k is 3 over 2, so 3 over 2f. So this is the equation that is connecting t and f. Now to the next question, we are told to find the value, what's the value of t if f is equal to 12, all right? So we'll come to this place, our t value, which is 3 plus 3 over 2, where our f is given to be 12. So you can actually just say 2 into 12 is what? Is 6. Then 6 times 3 is 18. So t becomes 3 plus 18, that's 21 as our t, all right? So that's for the first question. Then to the second question, which is number 2, w is partly constant and varies inversely as the square root of y. So we are only interested in w varying inversely as the square root of y at first, and then for introduction of the constant, which is a plus k over the square root of y. All right, so that's how it is. Then now we were given w as 7 while y as 9. So w 7 in the first expression, y is 9. Then the second expression, w is 6 when y is 16. So w is 6 when y is 16. Then we can get our simultaneous equation by substituting. It becomes 7 equal to a plus our k then over root 9. Then in the second equation we have 6 equal to a plus k over root 16. So taking the square root of 9 from here will be 7 equal to a plus k over square root of 9 is 3. That's equation 1. Equation 1, and then the equation 2, 6 is equal to a plus k over square root of 16 is 4. So equation 2. All right. So from here we can actually subtract equation 2 from equation 1 in order to avoid negative values. So 7 minus 6 is 1 equal to a minus a is 0. Then we are now left with k over 3 minus k over 4. And when we do that, it becomes LCM of 3 and 4, that's common denominators. Of course, it becomes what now? 12. We want to get a common denominator. So 3 into 12 is what? 4. Then 4 times k is 4k minus 4 into 12 is 3. Then that 3 times k is 3k. So 1 equal to 4k minus 3k, that's ordinary k. You don't need to put 1k there. Then over 12. So when it cross multiply, it becomes k equal to 12 times 1, which is the same as 12. All right. So that is our value of k. Then we can easily obtain the value of a. We can get the value of a. How do we get the value of a since k is known? So we can substitute it in any of the equations. So it becomes 7 in equation 1 now. A plus 12 over 3. In place of k now is now 12. So of course 3 into 12, that gives you what? 4. So it becomes 7 equal to a plus 4. When you collect like terms, it becomes 4 to the other side. That's 7 minus 4 equal to a. Therefore, our a equal to 3. So our value of a is 3, while the value of k is 12. All right. So now to the question, we are told to actually get the formula that will be showing the relationship amongst them, or rather, find w when y is equal to 144. Of course, we know that we can easily find w when y equal to 144 by simply working with the formula showing the relationship. And how do you get the formula showing the relationship? You can come to this part and substitute your value of a there and your value of k in this place. And that becomes, so let's just quickly work with this space. Sorry for the space because it's kind of small. Then now, our w is equal to, what's our a value? 3 is known there. Then plus, what's our k value? Our k value is 12 over root y. And don't forget, we are told to find w when y equal to 144. So it becomes w equal to 3 plus 12 over root 144. And root 144 is still 12. So w equal to 3 plus 12 over 12. So 12 cancels, that's 1. That becomes w equal to 3 plus 1 and W will be 4. So that's the answer to the question. So we are still going to look at just two more examples on word problem involving variations. So those are the two main examples I will just look at under the word problems involving variation. So this is word problems on variation. Now we are having two questions here. That is the first question here. Let's quickly treat on these questions. X is directly proportional to y, and y is inversely proportional to z squared. What is the relationship between x and z? So let's go. This is coming from joint variation. So solution to question 1, we have x is directly proportional to y, and y is inversely proportional to z squared. So now, if we want to get the relationship between x and z, it means that first, if you introduce a constant in this first equation here, this is equation 1 and this is equation 2, all right? Introducing a constant in that first equation, it becomes x equal to ky, and then the other one becomes y equal to k over z squared. And remember, I want to show a relationship between x and z, so it's obvious that we can substitute k over z squared in place of y in this equation 1. So that becomes x equal to k times k over z squared. And constant times constant is constant, so hence our x is equal to k times k is k over what? Z squared. So using the proportionality sign and removing the equality sign and that of the k being the constant, you can have x is inversely proportional to z squared. This and this, they are sort of similar in that after the introduction of a constant and equality sign here, it gives you this one. So what's now the link? X is inversely proportional to z squared. So that's the relationship between x and z, inverse relationship. Then for the second question, number 2, now we are told that v is partly constant and partly varies with b. This is actually on partial variation. When v equal to 150 and b equal to 450, and when y is equal to 200, b equal to 800, find the formula that connects v and b. So let's quickly dissect this. V is partly constant and partly varies with b. So we can just go like v varies with b, and that becomes v is directly proportional to b. By the introduction of a constant in obedience to this statement, it becomes v is equal to, we could use a as a constant plus, then we introduce another constant to this b, that's kb. You know that there are two constants in partial variation, so don't forget that. So from here, we can easily work with these values. We are given v to be 150 when b is what? 450. So v is equal to 150 when b equal to 450. And then that's the first statement. Then the second statement, our y, okay, is even y, not v, y please. So here is y, and y, all right? So then in the second statement, y is 200. So y is 200 when b is equal to 800. All right. So we can just substitute in place of this to arriving at a simultaneous equation from here. That becomes, in place of y, we put 150 equal to a plus 450k. That's equation 1. Then in the second equation, we are having 200 equal to a plus then 800k. That's equation 2. So just like what we usually do, we subtract equation 1 from equation 2. So that becomes 200 minus 150, that's 50, equal to a minus a is 0. Then 800 minus 150, that's 350k. So from here, I can divide both sides by 350 to get k. So 350. So this cancels this. Then of course 5 into itself is 1, 5 into 35 is 7. So therefore our k is equal to 1 over 7. So we can quickly use this value of k to get the value of b from any of the equations. So let's work with equation 1. So equation 1 has it to be 150 equal to a, then plus, then 450 in bracket 1 over 7. That's our value of k. So let's get a now. So this becomes 150 equal to a plus 450 times 1 is 450 over 7. So we can collect like terms from here. That becomes 150 minus, because when this one crosses to this side, it becomes minus 450 over 7 equal to a. So when you make this one over 1, you take the LCM. Now the LCM of 7 and 1 is what? Is 7. And then 1 into 7 is 7. Then 7 times this is 0, 5, 1050. Then minus 7 into itself is 7. Then, sorry, 1. And 1 times 450 is 450. Alright? So that becomes equal to a. So when you subtract 450 from 1050, you are left with 600. So 600 over 7 equal to a. Therefore, our a will be 85.71. So if our a is 85.71 and then our k is 1 over 7, then we are told to find the formula that connects v, y rather now, and b. Alright, so let's go. From here, it's very clear that we'll just come to this and impute the values of a and k, and that gives us the formula. So it becomes this becomes v or y rather equal to, what's our a value now? Our a value is 85.71, then plus, then our k value is 1 over 7, then b, or you can just simply write this as b over 7, because 1 times b is still b. So this is the formula that shows the relationship between our y and b. Alright, so that's the answer. So we are done with everything concerning variation. So it's my hope that you've been able to understand quite a number of things about variation. So don't forget to stay tuned to this channel and always visit the videos. Try to get yourself equipped for your exams ahead. All right, and don't forget to share the videos. Invite your friends to always be in this channel, so as for them to benefit as well. So thanks for watching and